This object has just been discovered. 3I-ATLAS was discovered on July 1st by the NASA-funded ATLAS survey. It was discovered using their telescope at Rio Hurtado in Chile, and it was first detected as a speck of light moving relative to background stars. We collected a good amount of data, more than 100 observations. We know its trajectory fairly well. We know it came from outside the solar system. Right now it's inside the orbit of Jupiter and is headed for its closest pass to the Sun at the end of October. That's going to be barely inside the orbit of Mars, and then it's going to keep going on its way out of the solar system. From images, we also saw that this object is active, which means that around the nucleus there is some coma, which is an indication that this object is in fact a comet. Right now, it's hard to say how big this object is because being active, the brightness that we see is partially due to the size of the object, but also it's partially due to the activity, and so we cannot really pinpoint the nucleus size directly. We have to better understand how active this object is, and then we can refine the size estimate and get a good idea. It's moving at a velocity of about 135,000 miles per hour, so it's going really fast. For that distance from the Sun, this is really exceptional. You have to be an interstellar object to be going that fast at that distance from the Sun. This object comes nowhere close to the Earth. It's gonna make a pass close-ish to Mars at about 30 million kilometers or roughly 20 million miles from the red planet, but nowhere close to the Earth. It's not gonna make a major close approach to any of the planets. So no risk from this object, just a scientific opportunity. The more data we get, the better we can measure the position of this object as it travels through the solar system and it moves out of it. But we also want to collect physical characterization data. For instance, we would like to understand better what the size of this object could be, the composition, the levels of activity. We're just bracing ourselves to get as much information as possible. We're really excited about these objects. So far, we've discovered 3 interstellar objects. The first one was Oumuamua in 2017, the second one, Borisov in 2019, and now we have the third one, 3I-ATLAS. So it's a rare opportunity, and as a scientific community, we want to collect as many data as possible to characterize this object and learn as much as we can.
Using NASA's Hubble Space Telescope, a team of astronomers captured the clearest image to date of the unexpected interstellar comet 3I-ATLAS. Astronomers are now able to more precisely estimate the size of the comet's solid icy nucleus. Its estimated diameter is no bigger than 3.5 miles across, but potentially as small as 1,000 feet across. Hubble captured a dust plume ejected from the sun-warmed side of the comet, and the hint of a teardrop-shaped dust hail streaming away from the nucleus. This behavior is similar to that of previously seen sunbound comets originating within our solar system. The big difference is that this mysterious visitor came from an ancient and unknown realm of our Milky Way, launching from an undetermined star system long ago and far away. In what may be the final chapter in its space odyssey, 3I-ATLAS is plunging toward the Sun at a staggering 130,000 miles per hour. This is the highest velocity ever recorded for a solar system visitor. The comet's astonishing speed suggests it has traversed interstellar space for billions of years. The comet gained speed due to the gravitational slingshot effect of the stars and other objects it encountered. The longer 3I-ATLAS traveled through interstellar space, the faster it moved. Hubble observations suggest that comet 3I-ATLAS was likely expelled from a developing planetary system. This occurred as icy bodies aggregated within an outer disk or ring surrounding a star, further supporting the idea that such outer belts are common in planet-forming systems. Another possibility is that 3I-ATLAS is just a fragment of a small icy planet that came too close to a white dwarf star, disintegrated under the stress of gravity, and sent its shards cannonballing back into space. 3I-ATLAS is an icy fossil from a time perhaps before Earth even existed. If 3I-ATLAS has wandered among the stars for nearly half of the Milky Way's age, it could provide insights into the history of our galaxy and the processes behind our solar system's formation. Comet 3I-ATLAS will make its closest approach to the Sun in October 2025, but don't worry, it won't be anywhere near Earth. NASA's assets, including Hubble, the James Webb Space Telescope, The Transiting Exoplanet Survey Satellite and the Swift Observatory will closely monitor the comet to measure its chemical composition as the sun's heat further sublimates its ices. Should it survive the perilous journey near the sun, the chances of 3I-ATLAS experiencing another close encounter with a star are incredibly remote. It's also possible that 3I-ATLAS, like many fragile comet nuclei approaching the sun, could break apart or disintegrate into dust, bringing its existence to an end. Before 3I-ATLAS entered the picture, we detected two other interstellar visitors. 1I Oumuamua in 2017 and Comet 2I Borisov in 2019. With numerous advanced observatories now scanning the skies, we should find many more interstellar objects visiting our solar system. Each new discovery offers astronomers valuable insights into both our own solar system and the distant universe beyond.